Hello everyone, this is Dr. Gajanan Jadhav and welcome in today's video. In this video, we are going to delve into one of the most fundamental pillars of classical physics, Sir Isaac Newton's laws of motion, which completely transformed our understanding of the physical world centuries ago. We'll start with Newton's first law of motion, which is commonly known as the law of inertia, and understanding how objects behave when they are at rest or moving at a constant velocity. Then we'll move on to the Newton's second law, where we'll explore the relationship between mass, acceleration, and external forces. After that, we'll break down Newton's third law of motion. Yes, the famous for every action there is an equal and opposite reaction, and understand what it really means in practical scenario. Toward the end, I'll give you a quick recap of all these three laws, followed by some examples to show how these principles apply in real world problems. So stay tuned and let's unlock the science behind motion together. So let's begin with the famous scientist Newton. Sir Isaac Newton's laws of motion explain the relationship between a physical object and the forces acting upon it. Understanding this information provides us with the basis of modern physics. So let's begin Newton's first law of motion. Newton's first law of motion states that if no force acts on a body, the body's velocity cannot change. That is, the body cannot accelerate. In other words, we can say that if the body is at rest, it will remain at rest. If the body is in motion, it will continue to be in the motion with the same velocity, with the same magnitude, and in the same direction. So unless and until we apply some external unbalanced force, that body will not move from where, if it is at rest, or if it is in motion, it will not come to at rest. Now let's study examples. There is a famous classical example of Newton's first law of motion is a soccer ball at rest on the field. So that ball will remain at rest unless and until we apply some external unbalanced force on it. So if the object is at rest, it remains at rest, or if the object is in motion, it remains in motion unless and until some external unbalanced force is applied on it. So F is equal to 0, where what is F? F represents the net force acting on an object. Now let's study some other examples of Newton's first law of motion. One of the best example, that leaves falling from a tree. This is one of the best example of Newton's first law of motion. Second, astronauts floating in air. Then a book on a shelf. We have one more example, that is a sled on snow. A diver of a diving board. A ball rolling down. If it is in motion, it will remain in motion unless and until some external unbalanced forces acting on it. A car which is parked, a parked car, it will remain at rest unless and until we apply some external unbalanced force on it. So these are the very famous examples in day-to-day life we experience, are the examples of Newton's first law of motion. Now let's start the equation for first law of motion. The equation for first law of motion is F is equal to dP divided by dt, or in another way you can write it as F is equal to d in bracket mv divided by dt, whereas P is equal to m into v, that is P is the momentum, m is the mass, v is the velocity, and t is the time, and whereas F is nothing but the force which is applied. So this is equation for first law of motion. Now let's go for the another, that is Newton's second law of motion. The acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass. This can be expressed by the equation that is force is equal to mass into acceleration, where F is the net force which is acting on a body, M is the mass of the body, and A is the acceleration. A large force will cause a greater acceleration for the same mass. A larger mass will require greater force to produce the same acceleration. And the example, that is pushing a shopping cart with more force will make it accelerate faster. A heavier shopping cart will require more force to achieve the same acceleration as a lighter one. That means more the mass, more will be the force required. Less the mass, less will be the force required for it. Now Newton's second law of motion formula, that is F is nothing but the force, M that is nothing but the mass of the body, and A that is acceleration, which is nothing but the acceleration of the body. So here is one of the example. The force which is acting on this particular plane, which moves the mass of that particular plane, and it moves with the acceleration A. Now this is the example. One more example where there is a mass having 400 kilogram. More the mass, it will require a more force, and here in another there is less mass, that is 40 kilogram. It will require a less force to move it. Now Newton's third law. This is the very famous law, which is called as the law of action reaction. So the statement is, for every action there is an equal and opposite reaction. When one object exerts a force on another object, the second object exerts a force of equal magnitude and opposite direction back on the first object. This is the Newton's third law of motion. And the forces which are acting on different objects, these forces act on different objects. And the example, when you jump, your legs exert a force on the ground, and the ground exerts an equal and opposite force on you, propelling you upwards. So this is example. Now let's move for some another examples. These are the examples. There's a person who is jumping out of that boat, so it will act a force, so there will be an action, and with the same action there will be a force of equal, there will be a reaction of it. Second example, there is one more example where there is a man who is acting a force, and therefore there accordingly there will be a reaction. Here is also one of the example. If you apply the force on that particular object which is of 100 Newton, so there will be a 100 Newton reaction. So every action there is an equal and opposite reaction. So these are the what we can say the Newton's three laws of motion. So thank you.